Good afternoon. We're Team TBD. We're going to be working on an autonomous UAV helicopter. So, brief introduction, we're basically researching, designing, and constructing a UAV platform. We'll be focusing on optimizing structure and design for the UAVSI Seafarer competition. And some of the key factors we'll be doing are GPS communication, optimal maneuverability, and image tracking devices. So a brief introduction to the competition. You're basically giving a fictional scenario where you have to search an area with the platform. And some of the things that the competition require are final journal paper, an oral presentation, and some flight demonstrations. The main objective of the competition is target acquisition. So you're basically asked to search an area and take images of certain points of interest and then send that information back to the main station with certain information. So for example, if you're given an object like that, you have to send back the shape of the object, the color of the object, the alphanumeric or the symbol, and the color of that symbol. Some global components of our project would be the countries related to the field. The United States and Israel would be the most related to our field. The United States is both the most frequent user and make the most UAVs. Countries such as Russia, Pakistan, and India, well-developed countries, have been long in the process of trying to develop their own UAVs, but have been unsuccessful due to lack in research and technology. Whether there be a market for our product in other countries, there would absolutely be a market. Like I said, many countries, well-developed countries, have been long in the process of developing their own UAVs. And our research and development can help aid these countries in their research. And one of the things we have to keep aware of is that the use of UAVs are strongly connected with military use. So we need to be aware that some of these organizations or nations that are interested may be using this for military usage.
Okay. Some global considerations for our project include cultural differences between the different countries, such as languages for manuals, and local colloquialisms. Local resources, such as voltage ratings for electrical systems, 110 versus 220. Fuels for engines, if they're available locally. System of units, metric or standard. And foreign laws, such as government regulation of radio frequencies, and private and commercial use of UAVs. So, for the computing devices on our project, we had an option between Windows, embedded Linux, or a microcontroller. For our project, we are running embedded Linux due to its open source nature. And we are deciding on an onboard system to process all the information. This saves us from having a disconnect from the base station and essentially having our UAV go haywire. So some of the components that we're going to use on the UAV include sensors such as barometric, which measures altitude measurements, ultrasonic, which increases the resolution for landing and takeoff, and GPS, waypoint navigation, which is important for our tracking system. And the accelerometer basically measures pitch, roll, and yaw, so we can control our helicopter. Some hardware that we're going to incorporate into our project is an autopilot flight controller, which basically does the algorithms for in-flight movement. A camera for image recognition. Miscellaneous servos, basically for wing flaps and rotor movement, so that the helicopter can move. Radio equipment, we need a manual override, so we need a pilot with a radio controller just in case the auto navigation fails. Data transmission back to the base computer to send the judges the information, and a laptop for data processing.
So for the competition to accomplish all of these tasks, we want to choose the best available platform. We're going to choose the helicopter because of its takeoff capabilities, its ability to hover over one area, its maneuverability, its stability, and it's a complex mechanical design. Here's our project timeline, roughly. Notice that we go a little bit over December into April because the competition is next year. Here's the budget for our project, coming into around $1,700, give or take, with prototype testing and any failures of parts that we have during testing. And here is the funding that we are looking for. Right now we're talking to the Senate Finance Committee in the main campus, and we've applied to 3 scholarships, and right now the team has $600 currently funded. And that is our presentation.
All right.
Do you have any questions?
So what happens if you don't get the money from one of these funding sources? Will you guys be able to complete your design?
Yeah, it just won't be top scale. We'll have to cut down costs.
We'll have to compromise.
We'll just have to compromise with
Sure.
certain material. I mean,
But
right now,
I would have contingencies in place just in case. You know,
Yeah, absolutely.
You guys will definitely need to have some sort of project.
Yeah,
at the end,
so
right? So yeah.
Just in case, as an example, we were looking for more funding from SGA. So due to the money that we got, instead of going with the Beagle board, which is a dual core processor, 1 gigahertz, 1 gig of RAM, we're going with the Beagle Bone, which is single core, 700 megahertz, half a gig of RAM.
Okay.
And
And
that's
that'll give you
almost
the
half
same
the
computing power that you need, or
price. Depending on exactly how much processing intensive, we may have to move on to off-board processing.
okay.
So we'll stream the video back to the laptop and then have that deal with image recognition.
Gotcha.
It's the
So
reality of the budget.
so let me get I'm just curious about the company. You have to send back, say, triangle. You don't send back a picture. You send back the words triangle or whatever.
Yes.
Yeah, a matrix of the different things you need.
Right.
So like that
So
example that I showed.
do you guys have some sort of image recognition software or something to try to do all that, or?
So the university has done it before.
Okay.
Some students have done it, and
Oh,
they've
okay.
created their own program. So we're gonna look at what they did,
Uh-huh.
try to make it better, try to see what they did, what they didn't do.
Okay.
We have something to work off from the university.
Okay.
Not to mention there are various open source resources such as OpenTV and I think it's called progressive.org,
Okay.
which deals with open source image recognition libraries.
Okay. And so what about the helicopter design itself? Are you, what's kind of, do you guys have a novel aspect to
we're
yours?
in the
or-
process of doing that design.
Yeah.
Because whereas fall has no summer, we have the summer to
Yeah,
work
you
with.
guys, this is kind of lucky for all of you.
We have, we have that ability to
Yeah,
use
yeah.
those 3-4 months
Right.
and work on the project within that time frame.
Right.
Whereas you only have a couple weeks
Yeah,
from
you-
fall to spring,
Yeah, right, exactly.
So we have that luxury.
Uh-huh.
So we're looking into that right now,
Okay.
designing the helicopter.
Okay.
On the helicopter design, are you using a tail roller or no tar?
Excuse me?
On the helicopter design, the tail roller, are you using a roller or are you going to be using jet, which is called a no tar?
No, we're going to be using the tail rotor.
Probably use a
That's in the budget already.
Okay.
Yeah.
And on one of your slides, I think it was one that said something about countries related to the field. Could you bring back that slide, please? Spelling error there in countries, so run the spell check on that.
Sure.
Yeah. All right, that's it.
I think you guys did a good job with your global impacts, though. Just taking a look at some of those, sometimes it's hard to come up with different things.
Mhm.
So you guys had a really nice layout of, hey, look, here are the issues with bringing this sort of thing to another country. Yes, it is. I think it's on the next slide, right?
Yeah, no, I actually found an article about
Okay.
Canada looking into like UAV programs from
Right.
the US, so we need to be aware of that.
Yeah, because that's a big issue. I mean, I know a lot of countries aren't big fans of these UAVs, especially once with image recognition and
Yeah.
all sorts of things
It's
associated
like
with
privacy and stuff. Yeah.
Yeah, right, exactly. So, that's certainly a big concern, so it's good that you can get through that.
All right, very good.